All right. Thanks for joining today, everyone. Today, we will be presenting one of our 10-minute webinars, Tips to Control Color for Building Materials. Presenting today is Tim Mao, our Applications Engineering and Technical Support Manager. I'm Robert Grotans, the Global Technical Marketing Manager, and I'll be moderating today's webinar. Just a few quick things to go over before we get started. Due to the number of people that are attending today's webinar, we will keep everyone muted. If you have any questions, please use the questions function on the GoToWebinar panel. Tim will have time to answer a couple of your questions at the end. If we don't get to your question, we will be sure to follow up. Finally, this webinar will be recorded and you'll receive a link so that you can review the webinar at your convenience. So with that, I'll turn it over to Tim to get things started.
Thank you, Robert, and welcome everyone. We're doing a 10-minute webinar here, so let's go ahead and get started. As the slide says, we're going to talk about building materials and controlling color within building materials. So let's dive right in. When we're talking about building materials, I thought it nice to just start with a picture like this to just get us thinking, because I'm guessing many of you who are attending are involved in different industries that are part of this, but we're literally talking about everything we can see here, right? From the stone to the siding to the windows, the glass in the windows, the shingles, the blinds that are on the inside, the door, the hardware, the deck that might be going out back. Eventually, they'll probably do some landscaping, and we might have colored mulch being laid down. All of those things, we kind of consider those building materials, and the reason we group them together quite simply is that they all present some very unique challenges when it comes to color measurement and how we would go about measuring and controlling that. So that's going to be the focus of what we talk about today. So we're going to start, let's dive in by looking at some different things we've got to deal with when we talk about building materials and the challenges that they bring. So the first is a lot of building materials are natural, right? They're produced by nature: wood, stone, marble, granite. We can go on and on. Lots of naturally produced things, but nature produces non-uniform color. Whether you're looking at a flower or a leaf or a piece of wood or a piece of stone, right? It's not all the same color. It's got non-uniformity, but that is really the desirable part of it. And so we could be talking about a piece of marble like this, where from a long ways away, that just looks like it's white, but as you get closer to that piece of marble, you see the darker and the golder kind of color pieces or striations through that piece of marble. The same thing with a piece of wood, right? We can see the grain, the light and the dark areas. That non-uniformity, that's the thing that's desirable, because something that's solid color looks fake, quite honestly, to most of us. It's either been painted or man-made, because nature doesn't produce solid colors. And so this non-uniformity is desirable. The difficulty is that customers want consistent non-uniformity, which is kind of a head scratcher sometimes, right? They want it to be inconsistently consistent. Now, what do we mean by that? What we're talking about with this piece of wood, for example, I'm going to blow it up so we can see it bigger, is actually a whole bunch of pieces of wood. And so this might be some wood flooring, for example. And if that's laying there, yes, we would say that color is consistent for the most part, even though we can see that the individual pieces of wood, their grain is different, their colors vary slightly, but together they look like good uniform color. So the question when we talk about natural materials is, am I concerned about the overall color like I might be with that wood, or the individual parts? Like maybe in the marble, I'm more concerned that I find multiple pieces of marble with that same shade of gold running through them than I am about their overall color. So let's move on then to some man-made materials. And many of them, the goal is to match natural, which means we're trying to control or actually make it be this and maintain this non-uniformity. And sometimes we've got to worry about avoiding things like a visible repeat. So here's some composite decking. And if you look closely, you can see the repeat in the grain that happens. Is that an issue? Not if this is my deck, I have no issue with that at all, right? I'm happy I have composite decking, so I don't have to do all the maintenance that comes with the natural wood decking, and all the other properties I gain, right? So I've got to deal with that. And I'm also going to be creating texture and embossing. For example, we look at this piece of vinyl siding. On the back side, it's going to be smooth, but on the front side, the side that will be facing to us, the user, the consumer, we've got texture. Why? To give it the look of that this is a piece of wood that's been painted. That's the goal, and that's what they're trying to achieve. But then the question, if I'm going to control the color of this piece of vinyl, do I measure the backside, which is smooth and will be very repeatable in measurement, or do I measure the front side where the texture maybe contributes a bit to some of my measurement difficulties? Now, trust me, we're going to get to talking about how we deal with these things. We're just presenting all of the challenges up front. So the third one I call near field versus far field. And when I'm talking about that, let's use shingles as an example. So looking at these shingles at this kind of magnification, right, from this kind of an angle, we can see the different colors in them. But if I'm standing in my driveway looking up at my shingles, they look fairly constant, more like a consistent color, right? And if I'm at the street, they may look like just a solid color. The closer I get to them, the more I see the various colors. So instruments measure small areas, 25 millimeters in diameter or smaller. There are some instruments that go slightly larger than that. But if I were to take that shingle and put it inside of my instrument in 25 millimeter aperture and capture the image, this is what I get. You can see the individual granules of particulate that are stuck in the shingle that are giving it its durability and wear as well as its color. But there's lots of different colors there. So an instrument's going to measure that. We don't tend to look at shingles or anything that's a varied color at that close of magnification. Typically, we're looking at it a lot from further away. And so if I measure that with an instrument, I'm actually going to get that color, that brown square in the bottom right there, because an instrument averages together all of the color inside the measurement aperture. And the reason that that works is because it's giving us what I call the far field view, which is the way the customer, your person you're ultimately hoping is happy with the product you're producing, is seeing this. And this is true whether it's shingles or I'm measuring anything else. I could be measuring cement, I could be measuring grout or mulch or anything, right? Even the vinyl siding, right? The texture's not visible from a distance. It just looks like a solid color, but the texture might make it look different when I'm closer. And so we've got to consider all of that. So how do we take all those things, all those challenges, and how do we get to a point where we can do a good color measurement and get good results? So we're going to start just by talking really quick about what products we might be using. A benchtop spectrophotometer, this instrument, the CI 7800, with a 25 millimeter aperture plate on it, is what I use to actually measure that shingle. I'm going to connect it to some software, running IQC software. We're not going to spend time talking a lot about the product specifically, more about things we need to have decided to be able to do color control. So first question is, I kind of made up a word here, but what are we QCing? What is it that we're trying to control? Far field color, what the customer sees, I call that product QC, right? So in that case, the measurement of the shingle in that aperture where it's averaging all those colors together is the right thing to do. The measurement of whatever it is we're producing. The vinyl siding, should we be measuring the backside that's smooth simply because it gives us a more repeatable measurement? My response would be no. We should be measuring the embossed textured side because that's what the customer is going to see. And we want measurements that reflect what the customer sees because that's how they judge the quality of the product. But if I measure that and we'll stick with the shingle. If I measure that shingle and the far field color is off, it's not good, then what? Well, why is it off? Is it off because the components, maybe the various different colored pieces of particulate in that shingle, maybe one of them is off color, right? So now I need to QC the components. In other words, I've got incoming particulate, probably in batches or whatever, right? And I may have to do some work there to QC that incoming pieces to make sure the color is right. Going back to the vinyl siding, if I get color measurement that's showing that that my color is off, I may at that point want to measure the smooth side of the vinyl siding, compare it to a standard to make sure, is the color of the vinyl correct, and maybe my embossing machine is not embossing as deeply or is embossing more deeply than it did before, causing a color difference. So we can start to do QC of the actual product, but also do QC of the components and various things to help us understand, because off-color pieces or embossing, all those kinds of things can contribute to the far field color issue. And then one comment last about natural color. We obviously can't change the color of marble. Well, we probably can find some way to do it, but that's not really what we're after, right? The customer is paying all of that money for his piece of marble because he likes the color of it and because he wants it to be a natural thing. So we're not going to be able to adjust the color of that, but we may be using an instrument to do more of a sorting function rather than performing quality control. So those kinds of functions help us identify pieces of natural products that are similar in color so that we can group them together when we need to make something larger. Now, when it comes to the actual measurement, it's really, really critical that we have a defined measurement process. So the preparation of the sample, do we need to cut something in order to measure it? Do we need to flatten something? If we're talking about measuring like cement, do we need to make sure it's cured for X amount of time? Because cement changes color for several days, and we can't necessarily wait several days to measure. So we might want to define at what time frame we're going to do measurement. What apertures to be used, what size, how big of a measurement area are we going to use? If I'm depends what I'm trying to accomplish, right? And then the area to be measured, specifically where. So if I'm doing wood and I'm going to measure a whole bunch of spots and average them together, then the where is maybe not quite as critical as if I'm trying to pick out and characterize part of the color of something, like the gold streaks, if you will, inside my marble, if I wanted to quantify that. Averaging, how many do I do? Well, that can be defined via testing. You can do measurements of your materials, and in our software, for example, do a series of measurements being averaged together, and you can evaluate things like standard deviation to be able to quantify, okay, the kind of variation in this particular thing that I'm measuring requires 6 measurements to average together to properly characterize it. So we can define those things, and we need to define them as well as orientation, right? Am I going to rotate the sample? Am I always going to hold it in the same orientation? If we can define all of these things, then what we get is a repeatable process. And if we've got multiple plants, or I need to communicate with my supplier or my customer, right, depending on where I am in the supply chain, if we're all doing these things the same way, then we get some repeatable results that we can share with one another. And ultimately brings us to putting measurements into software like this, where we can look at a pass and a fail perspective on my color. And I can look at the reflectance curves to see, is there some contamination going on? When I get some curves, if you look down at these reflectance curves, the blue and the pink curves have some kind of a contamination in them because their shape is significantly different than all the other curves. So something there is impacting those, and that can help point me to where do I need to go to fix my color, because QC is not just about pass or fail. It's also about when I do fail, why, and what do I need to go fix or address to try and improve that situation. All right, so we've already gone over our time because we try to make them short, but I want to share this with you as well. This information will get shared with you as well afterwards, as Robert said, a recording of this and everything. But this spot in our website has some really good information about building materials. It's got some links in here for various things, including a brochure that we have about building materials, talks about all of the various things that we measure. There's even some videos you can access that will show you how we measured wood and vinyl siding and a shingle with that instrument, the CI 7800, and the IQC software. So lots of resources for you to help you if you're looking for how to quality control your building materials, or if you're looking to how to improve that, and we're more than happy to help you with that. And with that, it will take us to our questions. So if you have a question, feel free to go into the questions tab and type that up. I'm more than happy to answer that for you. Again, I apologize for running long. 10 minutes always seems like it's going to take, like we have lots of time, but it really tends to fly by as we go. So one question I will answer that I see, asking about non-contact measurement. So we do have the ability. The instrument I talked about today was the 7800. We do have another instrument. It's called a VS3200 MetaView instrument, which does non-contact measurement. Because, for example, if I'm going to measure caulk or grout or even cement, those things may not be dry at the time that I want to measure them, and so having an instrument that literally needs to contact the sample is a problem. So that kind of an instrument does not need to touch the sample. It is truly a non-contact device, and so it allows us to measure materials that may not be dry, and in some cases, like caulk, never dry. We have the ability to measure those as well with another instrument. That instrument, the VS3200, also called a MetaView, METAVUE. That instrument also has the ability, because it's an imaging device, for us to deal very nicely with things like mulch, where I'm going to have something that has lots of holes and so forth in it, or stucco is another great example for that instrument. Stucco, you've got all the highs and lows and the shadows. That instrument will do very well in dealing with that. Okay, one other question I see, and I'll answer that really quick, and then we will move on. We'll finish up. So I have deviation in a multi-component building material, how to make correction. So I'll interpret that as something like the shingle, where I have lots of different pieces. How do I correct that? If it's multi-component like that are contributing to the overall color, you almost have got to go to the point of having the ability to QC each of the individual components first. And the same is true really if I'm making paint, for example, and I'm going to make blue paint, but it's a mixture of 3 different colors together to make this blue paint. It might be some white, there might be some blue, and there might be some black in it, for example. Well, if I'm not QCing and making sure that my incoming white and blue and black are the right color, and when I mix them together, multiple components coming together to make a new color, I'm going to have problems with that. So it's always critical that QC not only be an outgoing thing. Yes, we want to QC our products to make sure we are shipping and selling product our customer will like. But we're also customers, and we need to QC what we're receiving in to make sure that we can control better our color, so that we're not receiving something in that's off color. Now that just made my production process much more difficult. Right? So the incoming QC is as equally important as the outgoing QC. And that's true whether we're talking about building materials or, quite honestly, anything that you're measuring color for.
Great. Thank you, Tim. So that was the last question we have time for. So this does mark the end of our webinar. Again, if we didn't get to your question, we will follow up with you. You will also receive an email with a link to this recording, as well as that information that Tim just showed earlier. Thanks for joining, and have a great day.
Thank you all.